So this is a video that goes along with page 8 of your packets. And on this page, what we're going to be doing is checking to see which points are considered solutions to our function rules. Now, I want to remind you guys that the function rule is just the equation. And so for number 1, our equation here is going to be y equals 2x plus 3. And that's also called the function rule. In the last video, I mentioned that y can't function without x, meaning y, we have to rely on an input to get it. So we need an input x to get the output y, meaning if we don't have an input x, we don't get an output y, and it won't work. So in order for this to function, we need an equation where we have an x that we plug in and we get an output of y. Now, in general, for this page, all we're saying is that if something is considered a solution to one of these equations, that means it is a point on the line. That's all we're saying. Now, remember that our lines go on forever and ever, meaning there's technically an infinite number of solutions along the way, and it could go on forever, which is why we need an arrow. Okay? So we put arrows on both sides of our lines when we connect. Now this table of values here, in your notes, you don't have the domain. If you guys will just plug in, don't copy quite yet, just plug in this number onto your notes. Just write that down real quick. Okay? So for the domain, the first number we're going to plug in is a negative 2. 2 times negative 2 plus 3. Well, 2 times negative 2 is a negative 4. And negative 4 plus 3 is a negative 1. And that's how we get this negative 1. Now, we're going to plug in the next number. We're going to plug in negative 1. So 2 times negative 1 plus 3. Negative 2 plus 3 is 1. And that's how I get that output. Now, we're going to switch the input from a negative 1 to this 0. So 2 times 0 is 0, plus 3 is 3, and that's how I got this output. Okay? Now we're going to do 2 times 1. 2 times 1 is 2, plus 3 is 5, and that's how I got this 5. And now for the last one, we're going to do 2 times 2, which is 4. And 4 plus 3 is 7. And that's how I got that output. So now on your coordinate plane, the first point, we go back to down 1. And now we've got the first point. Now we go back 1, up 1. We've got the second point. 0, 3 is right there on the y-axis. I don't want you guys to forget that that's the one that's on the y-axis. If we go over 1 and up 5, there we are, and over 2, up 7. And when we connect, you should now have your line graphed. So that takes care of the first part where we simply graph the line. Now again, the whole point of the notes today is we're trying to find solutions to these lines. So now I'm going to ask you guys a series of questions. The first one I want to know is the point 2, 7 a solution? Meaning, is that on the line? So first on the graph, if we go over 2, up 7, yes, we can see that it's on the line. And yes, we can find it right there in the table of values. Now the next question I'm asking is the point negative 3, 3 a solution? So first, I'm going to look for it on the graph. And if I go back 3, up 3, right there, no, this point is not on the line. Now, up here in the table of values, we don't have the negative 3 as an input to look to see right there. But on the coordinate plane, we can see that it's not going to be on the line in blue. And for the last one I wanted to check, I'm asking, is negative 5, negative 7 a solution? Now, once again, it's not up here for me to check, but I can look at the graph and go back 5, down 7, And it is going to be a solution because if we kept that line going, boom, there it is. So yes, -5, -7 is a solution. Now for the first one, it was located both in the table of values and on the graph. And now what we're going to do is ask the same series of questions, but pretend we don't have the graph up above and we don't have the table of values. So notice I'm going to scroll down now, so I can't look at the table of values anymore, and I can't look at the coordinate plane. It's the same 3 points, though, that I'm asking you about up above. The first one I asked you about, we found it in green on the line and said yes. The second one in blue, it was not on the line and we said no. And the third one was in the yellow one. If we extended the line, it was on the line. So now what I'm going to do is teach you guys how to prove this algebraically. So we're up here for A, and I'm asking, if I plug in a 2, do I get a 7? So in this expression, if I plug in a 2 and simplify, I did get a 7. So if I plug in a 2, I do get a 7, and that's why I can say yes. Now in the next one, if I plug in a -3 and simplify, I get -3. So if I plug in a -3, -3 is the output. This is asking if I plug in a -3, will I get a +3? And that's why the answer was no. So -3, -3 would be the solution, not -3, +3. Now for the last one, it's asking if I plug in this -5, will I get a -7? And right here I'm plugging in -5, and when I simplify, I do get a -7. So since that simplifies to the output that I wanted, then yes, it is a solution. So for this next part, all I'm asking is for you to give your own solution to the function. So if this was the equation, let's say you want to plug in a 1. Well, right here, if you plug in 1 and simplify, we get 5. So y would equal 5. So your solution would be the ordered pair 1, 5. What I want you to do is I want you to pick a different number to plug in, and then you're going to get a different output. If you need a hint for what number to plug in, I'll give you a random number to plug in. Plug in a -4, if x equals -4, and tell me what you get. So if you need to pause right now to tell me the solution, when we plug in a -4, do so. So -4, -5 would be a solution to the function, meaning that that would be a point on the line when we graph it. And that takes care of page 8.